Hello everyone, let's look at Leetcode question 94, binary tree in order traversal. In this question we're given the root of a binary tree and all we need to do is return the in order traversal of its nodes, values. So that means we have to understand what in order traversal is, but before we get to that, let's look at the constraints. The number of nodes in the tree is in the range between 0 to 100. And the node values themselves are -100 to 100. Let's look at the examples. Okay, so here we have the solution and the in-order traversal. In-order traversal is the following: 4, 2, 5, 1, 3, 6. How does this work? Well, first we start at the top node and we go to the leftmost node. From the leftmost node we go back to the current node, which is 2. Since 4 is the leftmost child, 4 is a child of 2, then from 2 we go to the rightmost node, 5. That's 4, 2, 5. There's no more right nodes. We go back to the current node, in this case is 1. From 1 we go to the leftmost node. There are no leftmost nodes, so we go right, 3, repeat, 6. Alright, so to solve this problem, we're going to use a depth-first search approach. Here's the code and the example we're going to go through. So depth-first search is an algorithm that's recursive that allows us to use the idea of backtracking. It involves the exhaustive searches of all the nodes by going ahead, if possible. Otherwise, it just backtracks. So what we need to do first is start with a stack and answer as both empty. And then we're going to loop through root or stack. Remember, we're starting out with the initial value 1, so there is while root. Okay, 1 is true. While root, this is also true, so we can traverse stack.append root. Okay, 1 is added to the stack, root equals root.left, that's 2. Loop again through the inner while, stack.append. And so on until we reach the leftmost node, and there's no more root values, so we exit this inner loop. Next, root equals stack.pop. Okay, so we pop out the topmost value of the stack, and we append that to the answer array. So far we have 4 as the answer. This is so far true to the in-order traversal. Next, we do root equals root.right. Okay, there's no root values, so we go back to the top of the loop. And since there's no root, we are using the stack in the while loop to traverse it. Skip through the inner loop. There's no root. Root equals stack.pop. 2 is taken from the stack. It's added to the answer. Answer.append root.value. That's what we just did. Root equals root.right. It's 5. So root equals 5, while root or stack, while root, stack.append root, add 5 to the top of the stack, go left, there's no left values, pop it off, add 5 to the answer, and we go root.right. Okay, there's no right values, and there's no more roots. So we go back to the stack, skip the inner loop, pop off from the stack, 1 is added to the answer. As you can see so far, this is in order traversal. It's 4, 2, 5, 1. Next, root equals root.right. Okay, 1 to the right is 3. Remember root.right, so there is a root. We don't have a stack. While root in the innermost while loop, stack.append. We're just appending the 3, so we can pop it off outside of the loop and then add it to the array answer. Same thing for the next value. Add it to the stack, pop it off, and we have our answer. 4, 2, 5, 1, 3, 6. Alright, let's look at the code. Okay, here's the solution we just got over. And now let's look if it works. Nice, so it does work. It's a standard solution that uses depth-first search, and it iterates through every value in the correct order. Okay, so what's the time complexity? So the code traverses the binary tree in an order manner. And the worst case will be if we loop through and iterate through all the nodes of the tree. This will simply result in a time complexity of O(n) time, where n is the number of nodes in the tree. And the space complexity is constant, so that's O of 1. That's it for this video. Thank you for watching.